Hello everyone. In the first lecture we have gone through the basics of the system software or system programming, and in this lecture we will go through the basics of operating system. Operating system is nothing but a system program which is running on the hardware, and it is the interface between the user and the hardware. So in this lecture outline, we will go through the evolution of operating systems, functions of OS, where we will study what are the different functions of operating system. So what is a operating system? Operating system is nothing but it is a program, okay, or a software. It is a bunch of or a bundle of programs which are united, and it is an interface between the user and the hardware, so that in user can see or it can give some instructions to the OS, and by the help of the OS the hardware will operate and give some results to the OS. Then from the OS we will get some results. So it is an interface, or it is a program, or it is software between the user and the hardware, okay, to do some complex task. So for this it needs resources like memory, processor, input output, etc. to complete the task or these jobs. For example, suppose we want to compute something, like suppose we want to do some complex tasks, like to search an element in a 1.5 or 2 GB data, okay. So for searching we need some software to search, okay. For example, suppose we have written a program in Java to search an element in a database, okay. So for that we are installing that Java software or the MySQL database in the platform, that is operating system, which is a platform between a user and the hardware, okay. By installing the MySQL or Java, we can store the data and we can read the data by programming, and we can get the result from that. So it has many functions to provide better facilities to the users. Like you can know many types of operating systems are there available, like Windows 95, Windows XP, Windows 7, Windows Vista, then 8.1, then our Mac OS is there, then Linux is there. These are all operating systems which are basically made different Android, okay, which are basically made to solve the problems. So what are the functions of OS? So batch OS. Batch OS means basically operating system requires resources, and the resources are used to do some task, okay, and the instruction is called a process, okay, and the instruction what we are giving or supplying to the computer are using the resources and computing the problems and giving some results to the user. So what is a batch process? In the batch process many processes are there, so it makes a batch, okay. Then this batch are executed in the memory, okay, executed in the memory or loaded into the memory, and after that the CPU fetches the instructions batch by batch and give the results or output to the user, okay. Then what is multi-programming? It allows multiple programs to reside in separate areas of the core. So we know that memory is nothing but to store the programs in the computer, okay. So memory is the most important unit in the computer. For example, we are installing in your computer, you can see many softwares are there, or you can store many videos are there, many audios are there, many softwares are there. What you are installing, all these are going to the memory, okay, and in the core part they are stored, okay. like some parts are given to the videos, then audios, some parts are given to the software, some parts are given to the word processor, some parts are given to the multimedia, okay, some parts are given to the what your security softwares, like that. Okay, so in the core memory, operating system is providing some space to store the data. So it has a property of multi-programming. Then one function is known as paging. Paging is a memory management technique where the program is divided into equal size blocks called pages. Okay, and it is loaded into the frames of equal size. In simple paging, the pages of a program are loaded in main memory. In demand paging, only the pages which are required are loaded in the main memory. Okay, so paging is a memory management technique. So whenever we are executing a program, okay, so a program consists of many parts. So in paging technique, the program is first divided into pages, equal size blocks. So suppose you have written a program, in C compiler, and it is suppose 20 bytes, okay, it is suppose 20 bytes. Then pages are developed, means pages are of equal size. Okay, so the program is then divided equally, like 4 bytes, 4 bytes, 4 bytes. Then it is of 5 parts. It is converted to 5 parts, and the pages are directly loaded into the memory, means in the main memory. Main memory is a platform where the CPU fetches from the main memory and execute the instructions. So to execute an instruction of 4 byte, we place the 4 byte instruction, the page, from the memory, your hard disk, to the main memory, and the main memory has a frame of 4 byte, equal size 4 byte. It captures the data, the page, then the page is fetched by the CPU and the instruction is executed. Okay, so this is a technique called paging. So in simple paging, the pages of a program are loaded in the main memory. Okay, in demand paging, only the pages which are required are loaded in the main memory. For example, I want to give an example of demand paging. Suppose you have loaded a game of NFS or Counter-Strike in your or car racing. So you have seen that the game is 10 GB. The game is totally 10 GB, but your RAM or the main memory where you are fetching the instructions from the CPU, it is of only 1 GB or 2 GB or 4 GB, but your game is of 10 GB. So how the game is running? Because the 10 GB data is not loaded into your RAM. So how the programming is running? So there we are using demand paging. So in demand paging, whatever program or data is required, only that part is going to be executed. So for example, suppose in NFS you are in stage 2. So you are in stage 2. Suppose 10 stages are there, you are in stage 2. And in stage 2, the first screen is that some mountains are there and you are moving. So that is the first image. So the image is of very small size, okay, like KB or MB. So that MB is loaded to your 2 GB RAM or 1 GB RAM or 4 GB RAM. Not the stage, the last part of the stage is not loaded. Means whatever coming in front of you, that parts are loaded. Not the stage 3, 4, 5, 6 are loaded. So whatever the requirement is there, that is only loaded. So this is called demand paging. Okay, so for a instruction to execute, the instructions should be placed in the main memory or RAM, or from the RAM the CPU fetches the instruction and do some operations on it and provide the results to the user. Then like that, same segmentation is the same procedure as a memory management technique. The program is divided into variable size segments and loaded into memory. So here in segmentation, here in the paging, these are all of the pages are all of same size, but in segmentation the pages or the pages are of variable size segments, and these are all loaded in the main memory. Then what is scheduling? So scheduling is nothing but, suppose we have 50 processes or 50 processes are there. When 50 tasks are there, suppose in a C program you have written 50 tasks. Okay, each task has a execution time. Okay, for example, a task take 10 seconds, a task can take 20 seconds, a task can take 40 seconds. A task means some computations like x plus y, x star y, or x by y, like that. Suppose 50 processes are there. Okay, so by running a algorithm, there are many algorithms for scheduling. Means which process to be executed first, means which process to be executed in the memory first, that is called scheduling. Okay, means many processes are there, like round robin is there, FCFS means first come first serve is there, shortest job first is there. In first come first serves, whichever process is coming first, it is executed. Means suppose a process takes 90 seconds or 100 seconds, it is executed first. And if a second process is of 1 second, it is executed later. Okay, but in shortest job first, the process or the task with the lowest time is executed first. Okay, in round robin, suppose there are 5 processes, each have some times for execution. Okay, in round robin we are using the time sharing problem. The time sharing issue is there. Okay, sorry. So in round robin we are using a concept called time sharing. In time sharing we are giving a fixed time to each process we are giving a fixed time. Okay, for example, suppose 5 processes is there. First process takes 5 seconds, second process takes 10 seconds, third process takes 15 seconds, fourth process takes 20 seconds, and fifth process takes 25 seconds. So in the first round we are fixing a time. Suppose 10 seconds I am fixing in the first round. So in the first round process 1 will be completed because 10 seconds is given to process 1 and it is only of 5 seconds. Okay, and the second process is also completed because its execution time is 10 seconds, and the processor is allocated to it, and it is also completed. But process 3, 4, 5, they are not completed in the first round. Okay, they in the first round, and they are completed in the second round. In the second round, the same 10 second is given to all the processes, and the same thing will repeat and repeat and repeat till all the processes are executed. So this is called round robin. In each round we are fixing a time interval that is same in every round. Okay, then error handling. Error handling is a basic function of OS. OS can handle the error in the system and recovers from it. Thank you. So in this chapter we have studied about the basics of operating system.